I'm going to talk about the CT scan machine. Now, the CT scan machine was discovered by Sir Godfrey Hounsfield, for which he got a Nobel Prize. And the first one was installed at Mansley in England. And the CT machine consists of is an X-ray tube which rotates around a gantry, and it has a row of detectors which has increased from 4 to 8 to 100 even 64 to 128 slice CT scans are nowadays done. Basically, what do you mean by the 128 or 64 is basically the number of parallel detectors. It does not refer to the number of slices anymore, though it used to correspond with the number of slices in earlier times, when the number of, if it used to say four detector CT, then it also referred to 4 slice CT. But nowadays, even with a 128 slice CT, you can take a higher number of 128 detector CT, you can take higher number of slices. So these CT scans are multi-detector CT scans. And what is the method of image formation? The method of image formation is called as filtered back projection, in which the raw data is acquired and then it is thrown back onto the anatomically relevant image, and image reconstruction is done. There's a lot of physics to it, and we will not go into so much details. Hounsfield unit is basically a unit to measure the attenuation amount of the CT scan. For water it is 0, for fat it is -100, for air it is -1000, for blood it is around 80, and anything more than 150 will be like for generally calcification or calcium. Now, a cardiac CT is basically a multi-detector CT which has minimum of 128 slice, which takes a fast scan within a 0.3 seconds of the entire cardiac cycle. Now, earlier it used to be a progressive gating, in which what we used to do is multiple CT scans were taken with the heart in various phases of systole and diastole, and from which then the multiple CT scan images, the data was acquired and combined to form an image of the entire heart. But this it involved a lot of radiation, so nowadays prospective gating is done, in which a prospective gating is done, in which the ECG is taken, and when the ECG shows the finish of the R peak, then that is the start of the diastole, the cardiac scan is taken. And dual energy CT is the one in which there are generally 2 X-ray tubes instead of 1, and generally it gives a higher radiation, but a cardiac CT is always better in a dual energy CT. So suppose a 128 slice single source CT takes a cardiac image, and 64 slice 2 dual source CTs takes a cardiac image. The image in the dual source 64 slice CT will be better, because the temporal resolution, which should be a minimum of 0.33 for cardiac CT, is higher in dual source. Also, CT perfusion, basically what do we mean by CT perfusion studies? CT perfusion study is basically to find out the blood volume, the rate of blood flow, and the tissue perfusion of the contrast agent. Contrast agent is injected, and multiple CT scans are taken over a period of time to see the movement of the contrast, and through this we can understand how the contrast is interacting with the tissues, and that can be help to make an image. Well, that brings an end to this chapter.